Okay, now we have the terms under simple machines. So the first term we are going to treat is the mechanical advantage. Now followed by the velocity ratio, then the efficiency of a machine. So the question, what is a mechanical advantage? Now the mechanical advantage can be defined as the ratio of the force output. The force output, or you can call it the output force, to the input force. The force output or output force is the load, while the input force, the one you are applying, is the effort. So either you say that it is the ratio of the force output or the output force to the force input, or you say it is the ratio of what? Load to effort. So our mechanical advantage is simply mathematically mechanical advantage. I'll use M dot A to denote that is equal to load over effort, which is the same thing as saying output force divided by input force. This is just what a mechanical advantage stands for. Load over effort. Always remember this formula, or you say output force divided by input force. Then the next one is the velocity ratio. I will use V dot R to denote the velocity ratio. What is the velocity ratio? It is also defined as the ratio of the distance made by the effort. Please note this definition. The ratio means fraction, division. The ratio of the distance made by the effort divided by the distance made by the load. So this is the ratio of the distance made or covered by the effort over the distance made by the load. Why mechanical advantage is load over effort? Velocity ratio is dealing with what? The distance in a particular machine. The distance an effort was able to make divided by the distance made by the load. So velocity ratio is not dealing with force. No. It is dealing with length, distance, place. Why this mechanical advantage is dealing with what? Effort. Now, another important thing you should know about mechanical advantage and velocity ratio is they differ in terms of machine. This is standard. This is fixed. It does not change no matter what the machine is. Mechanical advantage remains load over effort. That is output force over input force. But velocity ratio, as you can see, can never be static. It is not fixed. It changes depending on the machine, because the distance a particular machine will cover if you apply a load. So if you apply an effort to the machine, can never be the same because all machines are not the same. But the load can always be the same. You can apply 20 Newton load to a particular machine, the same 20 Newton load to another particular. So this is fixed, but this is not. So each time you are treating each machine, you must have a different velocity ratio concerning that machine, because the distance covered by an effort can never be the same in any type of machine. Now, another thing you need to know about mechanical advantage and velocity ratio is in an ideal machine. Ideal machine. Ideal machine is also called a perfect machine. So what is an ideal machine or a perfect machine? An ideal machine is a machine that has 100% efficiency. So any machine that has 100% efficiency, which means it has no friction in it. A brand new machine, which is very difficult to get in real life, but let's assume that it is existing. So in an ideal machine, the mechanical advantage, please note this, is always equal to your velocity ratio. Your mechanical advantage is equal to your velocity ratio. But in other machines, it may not be the same. Some machines, mechanical advantage is less than your velocity ratio. But when the machine is idle, which means there is no friction. So JAMB can ask you, in a machine when there is no friction, the mechanical advantage is equal to velocity ratio, mechanical advantage is less than velocity ratio, mechanical advantage is greater than or, and so on and so forth. They can say mechanical advantage is equal to 0. So the correct answer is that the mechanical advantage is equal to the velocity ratio in an ideal machine, a perfect machine. Okay, let's talk about efficiency. Okay, by definition, what is efficiency? Efficiency can be defined in two ways. So the first here says, although they mean the same thing, efficiency is defined as the ratio of work output to work input expressed in percentage, or you say percent. So the unit of efficiency is percent. So you say efficiency is defined as the ratio of work output to the work input expressed in percentage. This formula is not that popular. This definition is not that popular. This is the definition that is very popular. But they always ask you questions based on this. And students always fail woefully. Remember this, very important. In fact, this particular definition is coming from here. So it's the ratio of work output to work input expressed in percentage. Or you say efficiency is the ratio of the mechanical advantage to the velocity ratio expressed in percentage. So anyone you like, efficiency is the ratio of mechanical advantage to the velocity ratio expressed in percentage. This, like I said, is gotten from this. So mathematically we are being told that efficiency is equal to work output divided by work input expressed in percentage times 100 over 1. So that is what efficiency is. Now, work means force times distance. That is what you call work. Work means force times distance. I want to show you how the definition can also, why we can call it mechanical advantage to velocity ratio. Now, force, work done is force times, so let's call it work output means the work done by what? The effort. Sorry, the load. So we have load. Let's just use L to denote the force, because load is a force, times distance. The distance, let's call it a small l. So force times distance divided by work input. Work input is the work done by what? Effort. So some textbook will say that here is work done by load divided by work done by effort. They are still the same thing. So let's use capital E to denote the effort, which is the force, times small e, which is what? The load. Sorry, the distance covered by the what? Effort expressed in percent. Expressed in percent. Remember, mechanical advantage is equal to load over effort. That is mechanical advantage. Then velocity ratio is equal to distance moved by effort over distance moved by load. So let's see if we can get that here. Now what we have here is load over effort, as you can see. Load over effort times, now what do we have here now? This is distance moved by load over effort. But what you are supposed to get is this, times 100 over 1. This is the denominator. So if I still keep load divided by effort as my denominator, if I'm removing the multiplication sign to put division, that means I have to invert this. So removing this to put division, this changes to effort divided by distance moved by effort divided by distance moved by load times 100 over 1. I hope you can see that. So what is up now? Load over effort, which is mechanical advantage. So our efficiency now becomes mechanical advantage divided by, it is being divided by distance moved by effort over distance moved by load, which is our velocity ratio times 100 over 1. So either you use this formula, which is the original formula of effort, of efficiency, or you use this. So this is more popular amongst students, but please, this, as you can see, is coming from here. So most times, JAMB will ask you a question on this, and students fail woefully because you are conversant with this. So be very, very careful. Efficiency is not only mechanical advantage divided by velocity ratio times 100%. No. This is also efficiency. So let's quickly go over to types of machines. So in each type of machine, we are going to be treating the mechanical advantage for each. Like I said, the mechanical advantage is the same no matter what the machine is. But for this is also the same. Efficiency formula is also fixed. It doesn't change, but the velocity ratio changes, like I said from the onset. So let's go over to the types of machines.